Hi guys, welcome to Learn Electronics Repair. One thing I don't have or didn't have in my test equipment is a scope multimeter or Scopemeter. I've always quite fancied having one of these, so I've got one of the ToolTop ET829. This is not a well-known brand. The price of this is around €120, a little bit over. And we can see it just comes in your plain box in a way and has a specification on the back. So let's get rid of the reflection and let's have a look. So 2 channels, trigger mode, nothing unusual there, 80 megahertz bandwidth, 200 mega samples per second. Takes probes 1 times, 10 times, 100 times. I don't know if it comes with those, but we'll see. It can store waveforms, so it says, normal coupling, and then we have the multimeter. So here is a spec of the multimeter. It has a continuity buzzer, but let's see if that works like I want them to work, which is 1 bleep for a diode junction or semiconductor junction and continuous bleeping for a short. Okay, I'll be lucky if it does do that, but we'll see. Current up to 10 amps, okay, DC and AC. So there we have it. I think we should just open this up and have a look to see what we have. Okay, so meter probes. Must be a charging cable unless it attaches to a PC for other purposes. One of the clip-on type scope probes and a proper scope probe. Does it say which one it is? Uses a little tip to tell you which model it actually is. Let's have a look. This is a 1 times 10 times probe, normal standard sort of thing really. Okay, the little coloured rings, these are just so you know which scope probe is attached to where really, if you're using more than one. This is a dual channel scope, it only comes with 1 probe, but that's how it is. Construction manual and the meter. Oh whoa, that is a big chunky thing. Okay, that is a chunky thing. There's a bit of weight in that as well actually. I mean, it's not overly heavy, but you wouldn't want to be holding that for a long time. I'll tell you, it will get notably heavy after a while. Maybe a few 100 grams or something, 500. Yeah, that's fairly hefty. What we have, stand in the back. Okay, yeah, that is standing at an angle that's very good for viewing, not good for recording videos, I would say. There's no screen protector on here from what I can see. Let's see if this thing has batteries in. Well, it made a bleep, I think. Oh yeah, and we have a display. Look at that. Okay, so it looks like we're in multimeter mode at the moment. It's saying, I think, connect your leads here. I mean, these are your normal leads positions here, milliamps, amps, common, and all the other ranges. Let's have a look at the multimeter first. I'll just have a quick look at the manual to see if there's any special things I should know about with this. It looks like the battery might not be very well charged. I'm not sure if that says it's fully charged or partially charged. So while I'm having a look at the manual, I'll just connect this to a charger. Well, yes, this does have a charging port on the side and the battery seems to be relatively low, so let's give it some charge before we go further with it. Okay, I have plenty of charge in this now, so let's try the multimeter first. And that, I should have said before, this font looks like something off Space 1999. Does anybody remember that? Yeah, that's kind of like what that looks like to me. Okay, yeah. I won't say funky because that's a definite misuse of that term, but retro. let's see. So I had a quick look at the instruction book manual. Okay, there seems to be a couple of interesting features of this. First of all, let's go for resistance. That's the thing we normally go for. So we hit this little symbol here. It says resistance. And then you can see we have functions 1, 2, 3, 4. So we have ohms, diode, bleeper, and capacitor. Okay. So ohms. Oh, it does an interesting thing there, which shuffles along with the decimal points. Okay, it must be set to auto range. I think we can set this to manual range actually. Let's have a quick look. So there's a button, yeah, auto here. So we'll hit this, and that I think that was on manual. Let's have a look. Yeah, it's not doing that weird thing anymore. Let's take some resistors. I like to start with some very low value resistors to see how it reads them. This one is a 0.3 ohms, 0.3 ohms. Let's see what it thinks. Well, it reads it as 0. That's not a good start. Can we change the range of this? Let's just go, see if we can change the range. I think we're in ohms now, yeah. So we press auto again. Now it can read it. Oh yeah, 0.3 ohms, that's nice. So if we hit auto again, what do we get? Kilo ohms. It's mega ohms. Ohms, okay. So I'm pressing that several times. Oh, you can see the decimal points changing there, yeah. So it's obviously, it has several different kilo ohm ranges. Okay, so it is actually reading the button. The same with mega ohms up to 60 meg. So we'll try a very high value resistor in a moment, and back to ohms. Yeah, that works pretty well. Okay, something a little bit smaller, 0.1 ohm. What do you think of this? It's close enough, you know. I mean, obviously there's going to be some resistance in the leads. Yeah, it's 0.1 of an ohm in the leads. That's fine. I'll go to the other end of the range. So 10 mega ohms is the highest value I have. Obviously, you need to make sure you're not touching the contacts, both of them, because your skin resistance will be considerably less than that. Okay. Kilo ohms. 600k, so that's 6 meg range. That's a 60 meg range. What do we get? I'll make a connection onto it so I get a good connection. Okay, yeah, it's reading the 11 meg. It certainly tells us it's a high value resistor. Okay, so not exactly accurate at that end of the scale, but it reads. We'll just try one more, something a bit more ordinary, which is a 100k resistor. So I'll leave it on the meg ohm range, see what it does. Yeah, I think it's reading, it's just where the decimal point is. Okay, auto ohms, that's a 6k ranging, so it's a 6k, yeah. So up to 6k, up to 60, up to 600. And that reads quite nicely. I'm not sure about this digit display. It's certainly different. You guys, what do you think of the meter display on that? Yeah, do you like that? Do you not like that? I have something I quite like about it. But there again, I was a fan of Space 1999, and for some reason it reminds me of that, yeah. Okay, so let's go on to the next range, which is continuity, which must be that one. Okay. Well, it bleeps fast. Yeah. It bleeps faster than the display, that's normal. So, yeah. That's quite usable. What happens in diode mode? So that will be this one. This is where I think it will fall down, because what I would like a meter to do, I always want a meter to do this, is in continuity, a continuous bleep, and on the diode, a single bleep. So we'll go to diode mode. This is a 1N5404, common 2 amp, I think these things are, okay. So this should conduct in the other direction. This should be open. Yeah. Diode range. And it doesn't bleep. I mean, it reads it, but it doesn't bleep. I'd like a single bleep on that and then continuous on short. But there's no bleeps at all in the diode mode. I suspect that is literally just firmware. I don't see why they can't just make meters that do that. I don't see why it's so difficult. But I have shown you guys why it's so important to have that feature when doing the electronics repair. Let's grab a Schottky diode. So this should read about 0.15 or 0.2, something like that. Yeah, 0.176. I do like the display, it's very clear, and I quite like this. So this is showing you where you need to connect to the leads for that range. The battery indicator, this has a rechargeable battery from USB, so that I also like. There's nothing worse than your meter going flat and you've got no batteries. Yeah. Let's take a quick look at an LED. So this is a red LED, should read about 1.3 or something in diode mode. See if this will read it and probably light it up as well. Or nothing in that direction. Let's go the other way. Yeah, it lights up quite clearly. Most multimeters will do that in diode mode, but some struggle to light the white or the blue ones because they have a higher voltage, basically a higher forward voltage. Let's see if this does. So this is a blue one. No, it's another red one actually. I thought that was a blue one. This is a blue one, but it's a pull. Okay, let's see if it works. Reads open in that direction. I mean, that may be a faulty one. I'll give it a fair chance. This is a new one. Okay. Not all multimeters can do this, by the way, but this one can. So it does light up 2.58. So this will test the various coloured LEDs. If it does blue ones, it'll do anything really. Okay, we have a couple other things we can try. Well, one other thing on this range, which is capacitors. Now, generally speaking, with multimeters, the higher the value of the capacitor, the longer it takes to read it. This is a 10 nanofarad. Let's have a quick look. Yep, worked pretty well. 47 microfarads. Well, either this capacitor's got a problem or it's not reading. Let's wait a bit. See what happens. Ah, you see, this is what I say about multimeters. The larger the value of the capacitor, the longer they take to read. But these capacitors are not very close tolerance, so 54 and 47, quite normal. And something much larger. So this is a 3300. Okay. How long does it take? And then we'll just see if we can change the range. Yeah, actually that's pretty fast for a multimeter. I have a capacitance meter which is just a capacitance meter that reads them instantly, but yeah, that was pretty good. Do we have some different ranges on here? No, it seems that the capacitance range is just auto, okay, on all. So that's your continuity and your basic component testing. Let's look at some voltages. Okay, so we have my power supply on 12.6 volts. Let's just attach some crocodile clip leads to the meter so I can easily work the controls while I'm measuring. So 12.67, yeah, that's fine. Okay, that's working. Now there's a feature this has where you can measure the difference between two readings, and not only on voltage but on resistance, and in fact on most ranges it serves. And this could be very handy, I think, if like you've got two PCBs the same as each other, where you measure on one, and then what you do is you press this button, okay, and then it will show you the difference between that reading and another reading. Now because the voltage is still the same, it's saying 0, okay. And you can see I'm increasing the voltage on here now to 14.7, and this is showing me the difference between the two readings. Press the trigger again, it'll go back to reading 15, okay, so 15.6, we just go up a little bit more, let's get it something level to a round number here. Depends how accurately I can actually set my power supply, not very accurately as you can see here. Now we hit trigger and the difference is 0. Now let's turn the voltage down, minus 2.7. I've not seen that on another multimeter, and that is quite interesting, I think, from a repair point of view. I'd like to know what you guys think. Maybe other multimeters have that, I just haven't particularly noticed, but I think that's pretty good, to be quite honest. I believe we can do that with resistances as well. Let's check that. So for example, if I take a 1k resistor here, we measure back into the resistance range, which is here, okay, and we measure, and you can see that's reading the resistance. So imagine I was measuring that somewhere in the circuit, okay. I press trigger. Now if I take, say, a 820 ohm resistor, which reads a bit lower, and I measure, look, minus 156 ohms, yeah. That is pretty handy, that. I can see this being useful, to be quite honest. Obviously you can take one reading and take the other reading, but you have to remember what your first reading was, and it's probably a lot easier to hit trigger, then measure the same place on another circuit board and just see if there's a difference. That is quite handy, I think. This, I think, could also be useful if you're trying to match resistors, you know, and op-amp circuits and such like. So we read a resistance, which is, this is 198.198k. I'll just change the range actually. Okay, I'll go to the lower range, 1 moment, and 2 ohms. I believe if you hold this in for 2 seconds, yes, it goes back to auto, okay? And then we can hit manual, so on mega ohms, 600 ohm range. That is 199. Okay, I've got my fingers across as well, so I'll just take my fingers away. But on a resistance like this, it won't make any difference, yeah? So we can measure that, hit the trigger. Now we can take another resistor of the same value. If they're the same, it should read 0. You can see the difference. That I like. Not only the difference, but the direction of the difference is positive or negative as well. But I do like that, okay? Let's just have a quick look at the resolution of the meter on the volts and current ranges. So on volts, if we put it into manual ranging, the most sensitive range is this one, which is 600 millivolts. So that will give me a reading to 0.1 of a millivolt or 100 microvolts. That's effectively the resolution of the meter. We have a 6 volt range, a 60 volt range, a 600 volt range, and a 1000 volt range, okay, which has a resolution to 1 volt. So that's the voltage ranges. Let's have a look at current as well. So on current, amps, okay. So this looks like the lowest range, which is 60 milliamps. So this will read down to 100 microamps, 10 microamps. So this isn't really good for measuring things like CMOS batteries, where I'm looking at currents between about 1.8 microamps to 10 microamps. 10 microamps is the lowest reading on here. But having said that, my Fluke won't do it either. I use my Aneng 8008 for that purpose, specifically because it has an extra digit. It reads down actually to 1 microamp. So that's normal for a meter, but it doesn't quite suit that purpose. Okay, I've attached my signal generator set to 10 kilohertz. That's actually saying 9.999. Okay, will you read the voltage of that signal? Let's have a quick look. So AC volts. Yeah, 3839 millivolts. It's not a very powerful signal generator, so that is actually telling me I can adjust the amplitude, as you can see there. Okay, so that works fairly well. Okay, duty cycle, what, 50%? Yeah, 31.4. I believe I have an offset set on the waveform. Let me just adjust it. Yeah. Okay, so I've now switched my signal generator to square wave. I'll just alter the duty cycle. Yeah, it's doing that okay. So it's measuring duty cycle quite nicely as well. I believe this will measure up to 10 megahertz on the meter and up to 80 megahertz on the oscilloscope. So I think that's the basic uses of the meter we've looked at. What's this one do? AWG. Oh, okay. There you go. That's a signal generator. Yeah, I think it stands arbitrary wave generator, but in actual fact, it only generates normal waveforms here, sine wave, square wave, and such like. Okay. I won't mess around with the signal generator, but it does do that. And it shows you here, this is the output from the signal generator. I'm a lot more interested in the oscilloscope. So let's look at that next. To activate the scope, you just press the buttons channel 1, channel 2. So if we press channel 1, that's activated the scope. Now this is connected to my signal generator, which is set to 10 kilohertz. If I press channel 1 again, you can see the options here. That probably isn't coming out very well on the video, but it's very clear for me to see. So I can tell you now, this says coupling AC or DC, probe 1 times, 10 times, 100 times. And there's a bandwidth limit you can switch on or off. For some reason my camera doesn't pick that up very well, but it's very clear to see. Try maybe like that. Yeah, you can see it now. To alter the time base is very simple. You just use the sideways arrows, so you can see there. Okay. And up and down is to alter the amplitude or the vertical sensitivity. So this is quite simple to do like that. Interesting, this uses a red waveform. Normally they use cyan and yellow. This is using red for this channel. If we want to put channel 2 on, just press channel 2. Again, we can set the coupling. I have channel 2 attached to the calibration output on my old analog oscilloscope, the Tektronix. It's a bit noisy, you can see. And you can see there, so I actually have both waveforms. It looks like it's triggering on one or the other. We can set the trigger level. Yeah, to set trigger, we press the trigger key. That's fairly obvious. It gives us the mode now. We can tell it to trigger, for example, on channel 2, because at the moment it's triggering on channel 1. Okay, so set the channel 2 trigger, and now it's triggering on the other one. Okay, I can now set the trigger point with F4. Yeah, you can see the little arrow at the side moving more into the waveform. Okay. There you go. So we're now triggering on the channel 2. So that works pretty well. You can also quite clearly see that the frequency of one is effectively pretty much an equal division of the other one, because the waveforms are both fairly stable. Okay. It's saying that the yellow waveform is 1 kilohertz and the red one is 10, and they are both pretty close to that, you can see. Okay, we can set cursor points on this, I've noticed in the manual. We can also display the frequency, the time, the voltage. I'll just zoom in a little bit. You can see in the little box here I have it set to 10 kilohertz. I'm still not sure why they didn't use a cyan colour here. It's a bit more visible. It's quite visible on the scope, but I think cyan would be better. To get it to display the frequency and voltage, I'll just show you how we do that. So we go into the menu, and then we choose what we want to display. So we're going to say volts. Okay. Voltage peak to peak, voltage max, whatever. We'll choose something. Voltage peak to peak. Then we press the menu again. And we can look at the display on here. We'll zoom in. And you can see there it's showing the peak to peak voltage and the frequency at 10 kilohertz. So that's working pretty well. There's one other thing I noticed with this, as well as having the manual setting for the time base and for the amplitude, we can also use the auto feature. This is like a lot of digital scopes have an auto feature, so we just set auto and it will set itself to give you the best display. Okay. That's what it's chosen for some reason. I actually thought it was working better before, but we can soon manually put it to what we want. Okay. I think I did a better job than auto, but maybe that's just me. Okay, so let's try the scope on my RF signal generator, see how much we can push it, how high it will actually read, and then let's just make a few checks on a motherboard, just probe around a little bit and see what we think. I have my RF signal generator attached. This goes to 225 megahertz. I'm using channel 2 just for the simple reason the display is easy to see on the camera. The red is not so bad visibly, but not brilliant on the camera, and I really don't know why they used red at all, as I said. Let's just hit auto, see if it changes that display at all. That's what it's happy with. And then we go to menu, and now let's display the frequency. So we go to time, press OK, OK on frequency. Okay, back out. Now I think menu will bring us out of there. And it's telling us there it is 7.2 megahertz, 7.1, 7.2. Okay, it's showing the voltage as well, that's fine. So if I press the button, we'll go up a band, so we're now on 10 megahertz. That's giving us a nice, stable looking sine wave compared to some scopes I've looked at recently, I'll be honest with you. 11.7. That does look like a sine wave. You can see the frequency going up, 14.1, 15, 17.6, 21. Now it's looking at a small amplitude there. I notice I have the bandwidth limit set to on. I'll just set that to off. Okay, let's change the waveform a little bit. Let's go up again. So that's on 27 megahertz, 28, 50, and 100, and now it sort of loses it. Let's just go back to auto, see what it thinks of it. It's back. Okay, so on auto it's back, but at 100 megahertz it can't give us a stable frequency reading. Then we can actually turn that down a little bit. Yeah, we can. I'll just set it to the correct range. I want to change the megahertz at a time. Okay, here we go. Well, the limitation of this seems to be close to what it says, 80, so I've just set it back to 80 manually. Let's hit the auto, let's see what we get. Yeah, so we have 80 megahertz. It's just about managing to display the frequency correctly. The waveform looks a little bit odd, but it is a waveform. Let's go up a little bit. So 81, 82, 83, 84, Yeah, I mean, it shows us a waveform there, but it's not really giving us a very good display anymore. Having said that, it's come back at 90. Okay. 2, 3, 4, 95. 96, 97, getting bigger. 98, 99. Can we get 100? Yeah, almost. So it will give me a pretty good display as far as 99 megahertz. I think for 80 megahertz bandwidth, that's pretty good. Let's just do a few of the usual tests on the motherboard. So we can power this up. It's a working motherboard. We can have a look around it. So first of all, real-time clock, which is here. Again, let's press auto, see if it picks that up. Well, it doesn't seem to see much there. Go to 1 times. Maybe try the other pair. Well, it was really thinking about that, but it hasn't really done very much. Let's change the time base manually. In the other cases I've used scopes, they did this just fine on all of them, to be quite honest. That doesn't seem too happy measuring that. Let's go for one of the VRMs. Let's have a look, see what we can see over here. Well, we see something there. Let's auto. Okay, yeah, you can see the VRMs running. Yeah, that's fine. Go back to this real-time clock again. See what it thinks. It must be running because the motherboard wouldn't boot up without it. Yeah, I don't see anything there. That's interesting. Maybe it's just me. Switch the motherboard off. Let's have a look. No. Okay. So look at the main clock, the 25 megahertz. That's back here on this motherboard. That's there. Yeah, it's got that, no problem. So why would you get the real-time clock? It's like it isn't sensitive enough to see it. Just picking up some noise. Frequency is that? Let's have a look. So menu, time, frequency. .32 kilohertz, so that is in fact the real-time clock. I can display it, but I can't display it on the auto for some reason. Okay, yeah, I misgot it, but and now auto does get it. Okay, guys, go and figure that one out. But that was a bit of a strange thing. I will definitely show this to you guys. So in that instance, it didn't really do exactly what I expected it to do. Let's go back to it. Yeah. Interesting. Okay. That's about the first time I've seen the auto thing fail on the oscilloscope on something simple like that. Let's look for the BIOS. Let's just watch this thing access the BIOS. So we'll go to the pin 1. I'll just change the sensitivity. This will put it back to auto. Okay, 100 millivolts per division. Switch it off. And then we should see a series of negative going pulses. Yeah, there. Okay, yeah, there. So that clearly is showing that this is reading the BIOS. By the time I hit the auto, it will have stopped doing it because it reads all the contents of the BIOS directly into the RAM. Okay, just switch it off again. Back on. Hit auto again while it's doing something. It doesn't surprise me that the auto can't really pick up a sporadic waveform like that. Auto really works well on a repetitive waveform, but if I do go to the pin of the BIOS, like the other scopes I've used, we can clearly see it's reading the BIOS there. Yeah, we can clearly see that. Okay, I've just increased the time base. This will actually go up to 5 nanoseconds, very fast. I'm now on 100 nanoseconds. You can see clearly that's the pulses that it's reading the BIOS. So yeah, this will certainly tell us useful things like that. So for repair, that's probably the most sort of likely scenarios we use a scope. Okay, so the ToolTop ET829. This is the first time I've actually looked at a Scopemeter. There are things I really like about it and things I really don't like about it, to be quite honest. So one I didn't mention, but these buttons feel kind of squidgy is the best way I can describe it. I don't really like the feel of the buttons. They work, they're positive enough. You get a bleep when it tells you it's pressed something, so it's okay, but they do look, I'm now in a menu by the way, you can switch the bleep on or off by the looks of it, and I've just mentioned it. So the buttons are a bit squidgy. It feels quite nicely built. I mean, the protective thing, this is kind of like a silicone, doesn't cover the whole thing of it, so I'm not sure how well this would respond if you dropped it. Parts obviously just plastic, okay. You can get a pretty good grip on it. It's quite wide. I suppose that depends on the size of your hands, but for my hands, which are not very big, although they're a little bit Wolfman-ish, okay, it's a bit awkward to hold in the hand. I would most likely hold this up on the stand and use it like that, to be honest. But you could hand hold it for me for short periods of time. If you've got bigger paws than I have, then probably for you, you can hold it a long time. The thing I least like about it is the red trace on channel 1. Why? Why not use cyan? It shows up much brighter. Everybody else does. And they don't use cyan just because like they copied everybody else. It's just cyan and yellow, the most visible colours against the black. Yeah. If I was using this as an oscilloscope, I would be using it in single channel mode pretty much all the time, and I would be using channel 2 pretty much all the time for that reason, because it's just more visible. Another thing I don't like about it, but this is true of just about every multimeter apart from my Fluke, is this business over continuity. I want a continuous bleep on short and a single blip on the semiconductor junction, but apart from my Fluke, I've yet to find another meter that does that, so I don't like that, but it's no different from just about every other multimeter. It's maybe just me on that one, okay? What I do like about it, I actually like this display. There's something about that is just like, to me, visually pleasing, and I expect to other people it's horrible. Yeah, so I do like that myself. There we go, and all its 1970s style glory, yeah. So there's that. What I very much liked about this meter is the way it had this difference where you could just hit the trigger to lock a voltage or a capacitance or a resistance reading, and then go to another component on, say, another board or just another component that's supposed to be reading the same, and it would tell you the difference between the two. And that feature, I think, really redeems just about everything that I don't like about it. Yeah, I think that's really, really good. I'm sure some of you guys are going to tell me you have all the multimeters that do that, but I really like that. Price wise, €120 or so. This is quite a busy marketplace at that price range. If you are working mainly with site work, or you want a tool that you can take on site with you, one tool that will do just about everything you want, then this I could recommend. It's definitely aimed at that market. And another thing, there are no metal parts around here, so you can connect this to hot ground on a switch mode power supply. Now when you do that, any metal on the test equipment becomes live. These metal parts will be live, okay, so you want those in a position where you can't touch them, and there's no reason why you need to put your fingers up there while operating this instrument when it's connected to high voltages. Okay, one thing I will check, and I just want to check this, is whether the common ground lead is actually connected to the metalwork there. Let's see, this is out of interest. So if I go to ground here, is that connected to this? No, it certainly is not connected to that, okay? Personally, probably if I was using this as a scope on high voltage, I would probably disconnect the meter leads, but I don't see any danger in leaving them attached in as much as, for example, meter is working. This would become live or hot ground. That would not be nice, but from what I can see, that is not the case, so I can not knock any points off of that either. So yeah, it's one of them, guys. This is one of them. Yeah, if a Scopemeter is what you need, I haven't tested any others to compare it with, so I can't really give you a comparison, but as a Scopemeter, I'd be happy to work with this. If, like me, you think that difference mode would be useful, and I'll have to try this in a few real life scenarios, then maybe that is a selling point if you're looking for something like this. I wouldn't say it's worth buying just for that, but it's certainly a selling point. So let's try this a few times. Yeah, I'll use it on the channel a bit, and probably on the electronics channel as well. In fact, we're going live on Sunday, so let's talk about this. Yeah, maybe some of you guys would like to come and watch the live show. That's from 5 p.m. London time tomorrow until 7 p.m. okay, that's 1700 to 1900 hours British time, London time, British summer time as it is now. So yeah, please come along and we'll talk about this one a bit more. If not, well, yeah, think about it. I quite like it. Nothing's perfect, but it's not bad either. The oscilloscope mode on this seems to work as well as other ones I've tried. It seems to support the 80 megahertz. In fact, I got it to about 100 and still displaying the frequency in the waveform. The auto mode didn't seem to work well on the real-time clock crystal. That's the first one I've tried that's failed out of maybe half a dozen scopes, but I could manually set it and I could see it clearly. So I'd say the scope is pretty good. Yeah, pretty good. Overall then, well, I think this comes down to what you want. If you're looking for something you can take on site, one single tool that will do pretty much anything you'd want to do on site, I think, depending of course on what you do and how specialised it is, but that is a pretty damn useful thing to have with you. Put a thermal camera in the bag as well, and I think you can probably diagnose a lot, probably the majority of things you're likely to come across, again depending on what you work on. Is it perfect? No. You've heard what I've said about the things I like and dislike about it, but the overall liking is pretty good. I'd be quite happy to use this. I have it now, okay. If this sort of tool is in your requirements, I don't think you'd be particularly disappointed with this one. Okay, I look forward to hearing from you all in the comments below. I also look forward to seeing you all again soon on Learning Electronics Repair. So for now guys, ciao.